Let me read the question again. A ladder is placed 7 feet away from a house on a wall that is 24 feet tall. Find the height of the ladder. So we are specifically talking about the height of the ladder. This in squiggly blue. So a squared plus b squared equals c squared. You always want to start with that formula. Good morning. Wait, I got some stuff for you. Here we go. It's the new stuff. So as I am looking at this right triangle right here, I need to decide where my legs are. So I'm looking for that L shape. Well, the L shape is right here at 24 and 7. Okay? So I'm going to say A is equal to 7 and B is equal to 24. Because we know that the hypotenuse, the longest side, is always across from your 90-degree angle. So then I substitute my values in. A is 7 squared plus B is 24, and we square that, and that is equal to C, that is my unknown, which is then squared. So take out your handy dandy calculator, put in 7, square it, that means push the x squared button, plus 24 squared, and tell me what you get for that answer right here. So 7 squared plus 24 squared equals, what do you get? Everybody should be doing this. Elijah, what'd you get? 625. Anybody else get 625? Very good. That's what you should have gotten. So you get 625 on your calculator is equal to c squared. At this point, you need to take the square root. The square root of any value squared is that base. So c is equal to, now, please pay attention here because I had a lot of people tell me I don't remember how to do this. To take the square root, you have to press the second key, then you press the x squared key because above that is what we're looking for, which is the square root symbol. Then you would press and put in 625 and finally enter. And after you do all that, what do you get for your answer? 25. And because we are talking about a length, and here we're talking about the length of a ladder, this is going to be 25 feet. So put 25 feet back over in the picture, and I want you to double check when you are looking at these right triangles with Pythagorean theorem. Make sure that the hypotenuse, this case, which is 25 feet, is larger than the lengths of the legs. In this case, it is bigger than 24 and 7, so that would make sense. Any questions on that? Okay, let's go to the last word problem here. Number 5 says, a summer camp is building a new zip line course. The designer of the course wants the zip line to start at a platform 450 meters above the ground. So here's the ground, and we want to start 450 meters above. So this is the start up here. Okay. And he wants it to end 775 meters away from the base. Well, here's the base. Okay. And so that is 775 meters away. How long must the zip line be to meet these specifications? So what we're looking for here is this amount, okay? Is that amount going to be my hypotenuse, or is that going to be one of the legs? The hypotenuse, yeah, hypotenuse. Because here is your right angle made with the ground and the height of where they want to take that starting place to. And across from that is the hypotenuse. So let's start with the formula. Always start with the formula. A squared plus B squared equals C squared. Okay, and if you want to help solidify that, these legs right here make the L shape. So I'm going to let A be equal to 450 and B is 775. So we're talking big numbers here. 450 squared plus 775 squared equals, my C is now X. And you could have left it as C. That was not a big deal. So take your handy dandy calculator. Big numbers here. So put in 450, press X squared to square that number, plus 775, press X squared, hit enter. And who is brave enough to say that number? Anyone? It is 803,125. Okay, that is equal to X squared, but we don't want X squared. We're looking for just X. So show me that you need to take the square root. Take the square root. The square root of anything to the second power is the base itself, which in this case is X. And if I take the square root of 803,125, that means I hit second and X squared, and I retype in that number and hit enter. And it says, anybody got an answer? Anyone? 896. And let's say we're going to round to the 10th place. The 10th place, tenths, is 1 decimal place. So that means I need to include one more initially. So I need 2. That's going to be 896.17. Which digit here is in the 10th place? The 1. So I need to stop there, but I need to see if I need to round it. So look to the right. 5 or more, yes. So this 1 is going to go up. So my final answer is 896.2 meters. And that is your final answer. Put that over here, 896.2 meters. And then double check, is that larger than the other 2 legs? Yes, it is. So that makes sense. Any questions with that? Okay. Let's turn the page. And now we are getting into the second part of our lessons that deal with right triangles. Okay? It says the word trigonometry comes from the Greek term trigon, meaning triangle, and metron, meaning measure. So the study of trigonometry involves triangle measurement. A trigonometric ratio is a ratio of lengths of 2 sides of a triangle. So the ratio is a ratio of two sides. So to remember the trig ratios, we use a mnemonic device, which means it's a kind of a word, it's a fake word, a fake term to help us remember these things, okay? So the trig ratios, the saying we use is SO, and that is S, capital O, H. So that is S-O-H. I know that's not how we usually spell so, but it is when we do this. Ka, that is C-A-H. C-A-H. Ugh. It would help if this would write. And T is Toa. T-O-A. Okay? So let me write out and tell you what each of these means. O stands for opposite, the opposite side. A stands for adjacent, adjacent. And H stands for the hypotenuse. SOHCAHTOA. Now there's kind of a funny story, because you're like, how am I supposed to remember SOHCAHTOA? That doesn't even sound like anything. Well, what do you do when you stub your toe? You SOHCAHTOA. Soak your toa. Soak your toa. You hurt your toe, so you soak your toa. SOHCAHTOA. Okay. All right, so here we go. The sine, cosine, and tangent. That is what the S and the C and the T represent. So the S in front of so represents sine, that you are taking the sine of some angle measurement. The C means you are taking the cosine of the angle. And T means you are taking the tangent. Okay? SOHCAHTOA. So the sine uses the sine of an angle, uses the opposite side, so that's the O. So we put opposite divided by the hypotenuse. So that's where we get the SO from. The sine uses the opposite and the hypotenuse. S-O-H. The cosine of an angle uses the adjacent length of a triangle divided by H, which stands for the hypotenuse. And finally, the tangent of an angle is equal to O, which is the opposite side from the angle, divided by the adjacent side. Okay? So it is very important for you to remember the phrase SOHCAHTOA. We are not going to give you that phrase. You have to remember it, and more importantly, you have to remember to spell it in this way. So it's S-O-H for so. Ka is C-A-H. Toa is T-O-A. So there's only 3 letters from the sine, cosine, and tangent that we use. So, ka, toa. All right, so it says in the first example, use the trig ratios and the triangle to find the ratios. Okay, So we are talking about finding the sine, the cosine, and the tangent of an angle. Okay, so let me put this up here. You are finding the sine, cosine, and tangent of an angle. Okay, but it is never going to be the 90-degree angle. It is not going to be the 90-degree angle. It's either, in this case, going to be angle A or angle B. It is never your right angle. Okay? All right. So as I look at this, the sine of angle A. So we're using angle A in this example. So I'm going to go ahead and erase this at B. Sine, if you remember, is the word, goes with the word so. So I'm looking for the opposite sine, opposite side over the hypotenuse. If you are coming from angle A and you go straight out from that side, the opposite side of angle A is going to be the side of length A. So in this case, that would be A over the hypotenuse, which is your C value. Okay? Is everybody with me on that? Oh, great. Let's see. Don't even know what to hit. Well, let me pause and see if this other thing will work. Is it back up? Okay. Okay. All right. So cosine of A. Cosine, we use ca. C-A-H. So the C is from the cosine, and we have to remember that we're looking at, in this case, the A for adjacent. So the adjacent side divided by the hypotenuse. Okay, so as I am looking at angle A, remember we're talking about the angle A. We have sides B, sides A, and C. C in this case is always the hypotenuse, right? A, side A here is always going to be the opposite side from angle A. That means the adjacent side. Do you know what the word adjacent means? What is it? Not the same. It means next to. So right here, Lenin is sitting adjacent with Elijah, or Elijah is sitting adjacent to Lenin. So next to. If I look at this angle A, the side that's next to it is going to be B. So this is the adjacent side. You might think, well, what about C? That's also right next to it. But C is my hypotenuse always because it's across from the 90-degree angle. So the adjacent side here has a length of B divided by the hypotenuse, which is C. Okay? And finally, tangent. That's TOA. So that's T-O-A. For the tangent, that means we have to put and find the opposite side divided by the adjacent side. So if we're looking at angle A, the side opposite of that is going to be length A divided by the adjacent side, which is B. Okay? Very important to understand this. So, does anybody have any questions about what we just went over? All right, let's take a look at the bottom. So, notice it asks us to find the sine of J, the cosine of J, and the tangent of J. So, first of all, we are going to look at everything from this angle J. Okay? I want us to go ahead and label opposite, adjacent, and hypotenuse. Okay? So, you tell me which side has a length that is the hypotenuse. What is the length of the hypotenuse here? I should be up here. 13. Yeah, this is the hypotenuse. Right? Because it's across from the 90-degree angle. Now, if we are talking about J, which side is opposite? Is it the 5 or the 12? 5, yeah. So this is the opposite side. And that leaves 12 to be adjacent, which is next to it. Again, you might think 13, but that's the hypotenuse. It can't be the hypotenuse and the adjacent side at the same time. So this is the adjacent side. So the sine of J, remember, SOHCAHTOA, S-O-H. So the sine is the opposite side divided by the hypotenuse. And I'm abbreviating here. The opposite side from J is 5. The hypotenuse is 13. So we are just comparing the two different sides here, a ratio of sides, 5/13. And that is your answer. Then next we're looking at the cosine of J. Cosine, we think CAH, C-A-H. For cosine, it is the adjacent side, always divided by the hypotenuse. And since we are looking at it from the perspective of the angle of J, the adjacent side is 12 divided by the hypotenuse, which is 13. Finally, we have the tangent, that's TOA, T-O-A, TOA. The tangent is the opposite side divided by the adjacent side. So that trig ratio is going to be 5 divided by the adjacent, which is 12. Any questions about that? Okay. Next up, now we're going to do the same thing, but this time we are using a different angle. We are going to use angle K. So let me make this a little bit bigger. Is that going to change some things? Yes. The hypotenuse is still going to be your hypotenuse. Okay? So the hypotenuse of your right triangle is always going to be the same. But now, if I am talking about angle K, the side opposite from K is now going to be 12. So you might actually like put them in a certain shape. Okay. So here's K. I'm putting those all in rectangles. Here's the hypotenuse and the side adjacent to that angle K. This 5 now becomes the adjacent side. So depending upon what angle you're talking about, the opposite and the adjacent sides are going to change. Okay? So here we go. Sine of K, that's SOH, S-O-H. That means opposite divided by hypotenuse. Now the opposite side from K is 12 and my hypotenuse is 13. Cosine of K, that's Ca, C-A-H. That is adjacent divided by hypotenuse. The adjacent side to angle K is 5 over 13. Tangent of K, that's TOA. That means the opposite divided by the adjacent side. And that is going to be 12 over or divided by 5. So with trig ratios, you never use the right angle, and your adjacent and opposite sides are going to change depending upon which angle you are using. The hypotenuse should always be the same. Any questions about that example 1? Okay, we are laying down the foundation of these trig functions, okay? Let's turn the page. Let me see what we have next here. Actually, we aren't going to do it, but we're going to change something. Based on what I just said, for example number 2, this should not be sine of t because t is the 90-degree angle. If we have r, this sine should be sine of angle S. So these all should be S's because we do not use the 90-degree angle. So we will finish that up tomorrow. And that is it, okay? So tomorrow we'll do bell work. We will finish this problem. You'll probably have some time to work on your homework. And I'm hoping for Thursday, if we really do go to a test and assessment on Friday, that we will have a review of something for you to work on, okay?